Welcome. It is my pleasure to bring you this training session covering the HAP wizards and how they can increase productivity. By saying HAP, I am referring to the Carrier Hourly Analysis Program. It is well known for its versatile features for load calculation and performing energy analysis for commercial buildings. It is also widely used for generating LEED, Energy and Atmosphere Credit 1 submission data. With the wizard, you can obtain operating cost results of competing HVAC systems quickly with no compromise in accuracy. Wizards save time versus traditional manual entry of all the project spaces, air systems, plants, and buildings. We have three objectives for this session. First, we will learn how to access the wizards from within the HAP program. Then we'll run a complete operating cost comparison of several different HVAC systems on the same building. We can then run the HAP reports to find the lowest operating cost of the three alternatives. Let's start by launching HAP. By the way, there is also a separate training session that covers launching the HAP software. I suggest you review it if you haven't already done that. I will use the default project preferences. There's also a separate training session dedicated to configuring project preferences that you should find very helpful. Let's now access the wizards. You could use this little icon up here in the toolbar, or go up to the word Wizards in the menu, and let's access the full wizard session. One of the attractive features of the wizards is the speed at which we can generate meaningful results. This is accomplished by a combination of using built-in defaults and graphical input screens to enter data. Before we start, a few words about our building. For our demonstration, we will use a 3-story, 90,000 square foot L-shaped office building in St. Louis, Missouri. We already did a takeoff to gather information on the internal load components, building envelope, areas, orientations, etc. That way we can concentrate on entering the data into the wizards. HVAC System Alternate 1 will be a floor-by-floor VAV system with a single water-cooled screw chiller. The heat will be provided by a natural gas boiler. Each zone will have a VAV box with hot water reheat coil. Alternate 2 will be a closed-loop water source heat pump system with a gas boiler, heat adder, and a cooling tower to reject loop heat. Each zone will have a reverse cycle water source heat pump unit. The wizards will accurately model the heat recovery feature of this system. Alternate 3 will be identical to Alternate 1 VAV system, except we will utilize a more efficient chiller, and we will add an air side economizer to the air handling units. Without using the wizard, this task could take quite a bit longer to finish. Without the wizards, we would have to configure the weather data in tabular form, define spaces one by one with tabular input screens, assign spaces to all the various HVAC air systems, configure the plants individually, add a utility rate, then finalize each scenario at the building level. Let's see how long it takes using the full wizards in HAP. Let's take a look at how to configure the three alternatives. First, we will click on the Weather Wizard. Weather Wizard is used to quickly set up design and simulation weather for a project. Design weather used for calculating loads, simulation weather data for calculating energy. This map of the world makes the job intuitive and fast. We will choose the USA, we will choose Missouri, then St. Louis for our project location, and hit OK. Next, we will use the Building Wizard to quickly create spaces using thermal blocking techniques. Traditionally, space creation consumes the largest block of time and effort in any software package. The Building Wizard can create a representative floor plan for a single or multi-story building quickly. Under Building Type, we'll pull out an office. Notice the other building type choices that there are: schools, healthcare, retail, lodging, religious, industrial, and entertainment. The building subcategory will be from 3 to 6 stories, a mid-rise building. We'll put a P for building identifier because this is our proposed building. The building can be figured by geometric shapes. Ours is an L-shaped building. Now our zoning method to create spaces into zones, we're going to say, is by exposure with corners. For this shape of building, we have all exposures, all corners, and core and perimeter split out for a total of 12 spaces, which will be 12 zones times 3 floors, or 36 zones created quickly. The dimensions of the building will be 200 by 200, 100 by 100. We will have 3 floors 30% window to wall ratio. We can spin the building on the site to get the proper orientation. The second screen of the Building Wizard allows us to put in our ventilation per ASHRAE. We will pick an office space and pull in Part 1 and Part 2 of the ventilation rate procedure. For our people occupancy, we will use 280 square foot per person and use the pre-done occupancy schedule contained within the Building Wizard along with the activity level. For lighting and plug loads, we will use the pre-done schedule and go with this value of 0.9 for overhead lighting and 0.75 watts a square foot for plug loads. For our building envelope, we can choose pre-done wall assemblies contained within the wizard, or we could have loaded in our custom wall assemblies, and then when we open the wizard, they would be available for us to choose from. We will use climate zone 4 through 8 above grade steel frame wall for our wall type. For our roof type, 2010 climate zone 2 through 8 insulation above deck roof. And for our windows for this project, we will use climate zone 4 metal frame compliant with 2010 ASHRAE window assembly. You can even have air changes per hour of infiltration if you'd like. Let's go on. Let's configure alternate 1, the floor-by-floor VAV system with water-cooled chiller. After alternate 1, we will go right through and add the water source heat pump system we discussed earlier. We will choose to go with the defaults in the wizards where we feel they are applicable, and that will save us time. Keep in mind you can always enter your own values for each and every input. Let's add the first system. It will be called VAV. Alternate 1. It will be chilled water. Air handlers, floor by floor with hot water reheat coils. There will be a VAV box, not fan powered, but a non-fan powered VAV box for each zone. There'll be 1 unit per floor, and it'll be an office start and stop schedule. We're going to leave the economizer out and add that under the third alternate. We can add DCV if we want. We'll choose not to here. Ventilation reclaim. We'll put a VFD on our supply fan. Under the Details button, we can examine some of the other defaults. The one we think will change is we'll approximate 3 inches of total static for each floor VAV unit. Go ahead and say OK, go with the other defaults, and move on now to the cooling system. We're going to have a chiller plant. There'll be 1 chiller. It'll be a screw chiller, and we'll go with the default for full load kW per ton. We can change the type of distribution system from constant speed to variable speed. We can have chill water reset. We can have variable flow on the condenser water side if we'd like. We're going to have a cooling tower. And we're going to put a VFD on the cooling tower. Once again, under the Details button, we can configure some of the other details behind the scenes. We won't have a 15% oversize on this. We'll use 2.4 GPM per ton and a constant speed system. And once again, we'll check to see that all of our Screen 1 defaults carried through under the Details. And sure enough, there's our variable speed fan on the cooling tower and 1 chiller, 44 degree leaving chilled water. We'll say OK. Move on to the heating system. We'll say that we have a 90% efficient gas boiler and that there's 1 of them. We will use hot water reset according to a schedule. And if we wanted to check the Details button, once again, we could make some changes. We'll take the 25% oversize default that's in the wizard and we'll make it no oversize. We'll use a constant speed distribution system and say OK. We can finish, and there's our alternate 1 VAV system. Let's add another one. Okay, for the second alternate, we're going to say it's a water source heat pump system. We will call it alternate 2. The VAV system was alternate 1, and we will pull down closed loop water source heat pumps. It knows there's 1 per zone. It will use an office start and stop time. We'll use the default EER and COP. And for the DOASH unit, the common vent unit, we will say it's on the loop itself as a water source heat pump unit. We'll also put reclaim in it, an ERV. We can go to the Details button, and this will give us, once again, some information on some details, we'll take out the oversize for cooling and heating. And we'll use 0.75 inches of total static for our fan heat. And we'll use these set points. We'll also make the energy recovery ventilator in the dough ash unit 60% and say OK. If we say next, this will be the heat adder and the heat rejector. We'll use a 90% efficient heat adder, and we'll say that the heat rejector, the cooling tower, has a VFD on it. And we can say finish. That was quick to put in our second system. Now we can copy the VAV system alternate 1, call it alternate 3, and basically what we wanted to do here was we wanted to add an economizer and also use a more efficient chiller. And we'll say 0.6 kW per ton full load. We can hit next and finish, and we have our 3 alternates. Now we'll close out. Lastly, we will use the utility rate wizard to rapidly set up utility rates for electricity, gas, oil, or propane, or other fuels. You can enter a simple or complex rate with variables like energy charges, time of day pricing, and demand clauses. The utility rate wizard also contains the U.S. state average energy and fuel prices compiled by the Energy Information Administration. These are built right into the wizard. You also have the choice of inputting your own detailed utility rates. We'll go ahead and pull down the EIA rates for Missouri, where this project is located. These are the latest EIA rates from the Department of Energy. When done with the utility rate wizard, we will say finish and run the operating costs at the building level right from within the HAP program. Notice the wizards have populated HAP with all the finished weather, spaces, air systems, plants, and buildings for our 3 alternatives. We can highlight them now and run the operating cost. We'll ask for the annual cost summary. I notice alternate 3, the VAV system, has the lowest operating cost. Several features contribute to that result. It uses an airside economizer and a higher efficiency water-cooled screw chiller with excellent part load characteristics. Also, the fans are equipped with VFDs for airside savings at part load conditions. Since the full wizard project configuration is now implanted in the HAP program, you can choose to modify the data within HAP and rerun results if you wish, or you may want to make the changes by running a standalone wizard. We will cover standalone wizard operation in a separate training session. Using built-in defaults and graphical input screens allow the wizards to accomplish time-consuming tasks very quickly. The wizards are perfect for scoping out the lowest operating cost among several alternatives. Even if some of the inputs are not an exact match to the real building, you will still end up with an accurate relative analysis. Having obtained the operating cost results, you may now wish to do a life cycle evaluation also. Life cycle analysis will be the subject of a separate session. This completes our training session on using the HAP wizards. I hope you found the information useful. Please make note of the software systems email shown here and send us any questions you may have on this topic that we just covered, or any other topics related to HAP such as licensing and training. Thank you for attending.